Good evening, good evening. I hope you had a blessed day. I've got with me a paper from Pumalanga. I've got a paper with me from Pumalanga. I'm gonna do the short questions, the ones that are out of 7, and other ones are also out of 8. These are the ones that I'm going to do, which are more or less low order questions, low and middle order questions. So I'm gonna do the multiple choice, I'm gonna do the match questions, covering geomorphology. Right, let's go through the questions. That is activity 1. Various options are provided as possible answers to the following questions. Choose the answer and write only letter A to D next to the question numbers 2.1.1 to 2.1.7, e.g. 2.1.8D. So this is multiple choice, so which means the instruction that you are given here is you are supposed to write the number and the letter which actually shows the option that would have chosen from the options that are given. Okay, the point where a river in the network joins another. So the point where one river in the network joins another. So what are we talking about? It's not an interflow, it's not a tributary. We are talking about what we call a confluence. We are talking about what we call a confluence where the two rivers meet. That's what we are talking about, which means our answer there is what? Is C. Let's move on to the next one. The ridges of higher ground between individual channels of the stream network. Which means, remember, this one is within the same drainage system. Is this within the same drainage basin? Okay, so it's a higher ground between channels of the stream network. So it's within the same river system, it's within the same drainage basin. So that makes it an interflow. That makes it an interflow because it's within the same within the channels of a stream network. So it's within. It's not dividing two river systems. It's not a high ground between two river systems or two drainage basins. So the correct answer there is to interflow. The ridge, high ground between individual channels of a stream network. So that's an interflow, which is B. Then water flowing through the cell is called 2.1.3. Water flowing through the cell is called. Remember, this water is already underground. The water is already underground. It's flowing through the soil. It's not a ground flow. It's not having a surface runoff. We call it through flow. It's flowing through the soil. We call it through flow. We call it what? Through flow. That is C, 2.1.3. That is through flow. That is the correct answer then. So here's interflow, there is confluence, there is through flow. The factors that increase surface runoff. The factors that increase surface runoff. So from the factors that we are given here, we have got steep gradients, we have got gentle gradients, we have got more vegetation, we have got what? Less vegetation. We have got less vegetation. So let's look at this. Steep gradient, which means as soon as the water flows, it starts to flow. It is not given time to settle. So which means this one increase surface runoff. When we have got a gentle gradient, it means the water is allowed to settle. The moment it settles, which means it increases more infiltration. It increases what? More infiltration. So this is wrong. With more vegetation. So what happens is when it rains, the water or the rain is intercepted. So when it gets to the ground, it's given more time. It can actually encourage more infiltration than surface runoff, because when it gets to the ground or to the earth's surface, it does not reach the earth's surface with more power, which means it is more like in shower form, which allows it to infiltrate. Okay, so more vegetation encourages more infiltration. If there's less vegetation, which means more water is reaching the ground with too much force, which close the pore spaces, which allows it also to flow. So which means these two increase surface runoff. Because rain, when it falls, is intercepted with more vegetation, which encourages more infiltration. So steep slopes and less vegetation, which is 1 and 4. So our answer here is D. The rivers have their source in a humid, rain region, and then later flow through a dry, arid region. Remember, when we talk about the types of rivers, of course, the answer here is an exotic, which is A. An episodic, it only flows as soon as it rains. That's what an episodic river is. It only rains as soon as we receive the rain, then it starts flowing. That's what an episodic river is. As soon as we receive rain, then an episodic river, what does it do? It flows. Then when we talk about a periodic river, this is a seasonal river. Which means if we receive rain only in summer, which means this is when we see these rivers flowing. That's what makes it seasonal. That's what makes it periodic. Permanent river is more like a perennial river. It flows throughout the whole year. So the correct answer there is exotic river, which is A. Let's move on to the next question, which is 2.1.6. 2.1.6, it reads, the factors that will cause a low drainage density. So what you need to understand is, what is drainage density? Is the total length of streams per unit area. So when you talk about drainage density, low drainage density, which means there's bound to be more infiltration and less surface runoff. This is what results in low drainage density, which means there should be more infiltration and less surface runoff. So let's see from the factors that are given here, which one encourages more infiltration and less surface runoff. This is what results in lower drainage density, which means less streams flowing. Factors that will cause low drainage density, what do we have? 2.1.6. We have got areas with high evaporation rates, which means obviously areas with high evaporation rates, which means less streams are likely to flow. So this is a factor that can actually cause low drainage density. What else do we have? Regions with higher rainfall, which means if we have got more rainfall, we are likely to have more streams flowing. This one is wrong because it does not result in lower drainage density. Then what else do we have? Large amount of infiltration, where we have got more infiltration, which means we have got less streams flowing, which results in low drainage density. Then areas with softer rock, okay, what is not clear is, this softer rock, are they porous, are they permeable, are they porous or permeable? Because we need to be specific. How soft is the rock? Does it allow water to pass through it? So the most correct answers there is areas with high evaporation rates, which is 1, and large amount of infiltration. This is what encourages low drainage density, which means our answer there is what? 1 and 3, which is what? C. Then the amount of water across the width of a river flowing fast a point in a given time is called the 2.1.7. This is what we call the discharge of a river. So this is what we call a discharge of a river. So I'm done with this one. This is a short question that is out of 7. Let's move on to the next one. Activity 2. It reads, refer to the sketch of drainage density below. So drainage density, remember what I said, is the total length of streams per unit area. That's what drainage density is all about. So we have got 2 drainage basins. We have got A and B. Which one has got more streams? You can see here, this one has got more streams, this one has got less streams, which means here there is a higher drainage density, there is a lower drainage density. This is what the concept is all about. So where we have got more surface runoff and less infiltration, we are likely to have more streams flowing, which give rise to B that we have, which has got a higher drainage density. Where we have got more infiltration and less surface runoff, we are likely to have a lower drainage density, which is what we have at A. Let's go through the question. Choose the most correct statements below that match the drainage basins about. That is this one and this one. Write only the letter A or B next to the question numbers 2.1.1 and 2.1.8. The drainage basin has soil with little moisture and high infiltration. It's got soil with high infiltration, which means high infiltration, what does it do? It encourages more, if there's a higher infiltration, which means there's reduced surface runoff, which result in low drainage density. So which means this is A, which means this is what? A. Then drainage basin with very little vegetation cover. If it has got very little vegetation cover, which means now it encourages more surface runoff. Because when it has got more vegetation, which means the rain before it reaches the ground, it intercepted, then it encourages more infiltration. So if it has got little vegetation cover, which means there's bound to be more surface runoff, which means it's B, the one that has got more streams. Okay, let's move on to the next one. Then the drainage basin has gentle slopes. The drainage basin has gentle slopes. Gentle slope, what does it do? It encourages more infiltration. It encourages more infiltration if it's gentle slope, which means it results in A. It results in A. Gentle slope encourages more infiltration, results in A. So which means the answer here is what? Is A. Then the drainage basin has higher porosity and higher permeability. It's also A, because where there is higher porosity and higher permeability, which means there's more infiltration that is taking place. So it's A. Then the drainage basin with low evaporation, 2.1.5, it has got low evaporation, which means there is more water that can flow, which results in B. That is a higher drainage density. Drainage basin with steep slope. If it has got steep slope, which means as soon as it rains, which means we have got more streams flowing because water is not allowed to settle, it results in this B, which has got a higher drainage density. The answer there is what? B. The drainage basin has got a low porosity and low permeability. What it means now is it encourages more surface runoff because there is reduced infiltration. So it means here is what? Is B. The drainage basin with high evaporation rate, which means we have got less water, okay, available, less moisture, which results in A. That is, we have got less streams flowing. So the answer there is what? Is A. So you see, I'm done with the second short questions. I'm moving on now to the next one, which looks at the drainage patterns, It reads, column A describes characteristics of a certain drainage pattern. Column B gives the possible drainage patterns. Choose the correct response. Only write Y or Z next to the question numbers, e.g. 2.2.9Z. So you have got this description like of the certain drainage pattern. Then you have got the two options that are given here. So you are supposed to choose the one that matches what is described in A. So let's move on. Where underlying rocks are uniform in their resistance to erosion, that one is your dendritic, which means this one is Z. Underlying rocks with alternating bands of hard and soft rock, 2.2.2, that becomes your trellis. This drainage pattern is common in areas with volcanoes, hills, and domes. Okay, this one becomes your radial. Okay, it's from a high central point flowing downwards. That's a radial. Then short tributaries joining mainstreams at right angles, 2.2.4. Short tributaries joining the mainstreams at right angles, that is 2.2.4. That is your trellis. The tributaries, they join the mainstream at right angles. I know also when it comes to rectangular, you've got the mainstream that is bending and also the short streams doing the same thing, but it's more appropriate to the trellis. That is the correct answer there from the options that are given. Streams flowing into a central pan or a low-lying area, which means that is your centripetal. Okay, that is your centripetal. Okay, then 2.2.6 forms an igneous rock that has joints and cracks. That is 2.2.6. That is your rectangular. Develop on land surface that was covered by ice sheet or glacier. That is your deranged. Then develops on a surface that slopes uniformly but is fairly steep. This is your parallel. That is your parallel. That is your parallel. So where underlying rocks are uniform in their resistant erosion, that is your dendritic. Underlying rocks with alternating bands of hard and soft rock, that is your trellis. Then the drainage pattern is common in areas with volcanoes, that is your radial or centrifugal. Then short tributaries joining the main streams at right angles. The short one, remember, it's more appropriate to the trellis than it is to the rectangular. Streams flowing into a central pond low-lying area, of course, that is your centripetal. Forms on igneous rock, that is joints and cracks, that is your rectangular. Then develop on land surface that was covered by ice or glacier, that is your deranged. Then the last one develops on a surface that forms uniformly but is fairly steep, that is your parallel. So this takes us to the end of our 3 activities. Thank you.